How's it going, everybody? Today I'm going to be talking about how prostaglandins are derived from eicosanoids. So, to start, how our message is sent to cells throughout the body. The body has a lot of different things it needs to do in response to different stimuli. And the way it's going to get this done is going to send hormones from organs such as the pancreas or different glands. And these hormones are going to bind to specific receptors on different cells throughout the body. So, essentially, these hormones are just messengers that these organs are going to send to elicit different responses in cells to respond to different stimuli and to respond to the needs of the body and the organism. And most hormones are derived from amino acids that are made in specialized organs like we talked about, like such as the pancreas. So what's the difference between a traditional hormone and an eicosanoid? So eicosanoid, they're produced by pretty much every cell type. They're not just produced in the pancreas or from glands and secreted into the bloodstream and carried throughout the body. They're made within cells, and they're called local mediators because they typically just send signals within one cell or to cells that are located close by. The reason that they're only local mediators is because these eicosanoids, they can be degraded very rapidly, where other hormones they can be sustained longer on their own. So how are eicosanoids produced in the cell? So arachidonic acid is a acid that's found in the phospholipid bilayer. And when activated, phospholipase A2 will cut the arachidonic acid out of the bilayer. It'll be freed here, as you can see, the structure of arachidonic acid. So after arachidonic acid is released, it can be modified in a variety of ways. We're really just going to focus on the COX enzyme here that is going to make prostanoids, which will go to become prostaglandins. However, if cytochrome P450 epoxygenase acts on arachidonic acid, it can be made into this here, the EETs. And then if LOX enzyme acts on it, it can be made into in these here in the lipooxins and leukotrienes. So again, there's a lot of variability out of arachidonic acid. We're going to focus primarily on prostaglandins, but just know that once arachidonic acid is available in the cell, it can be modified in a variety of ways. So COX enzyme, it can modify eicosanoids to make prostaglandins. So cyclooxygenase enzymes convert arachidonic acid to prostaglandin H2. And once it's at PGH2, many different derivatives of prostaglandins can be produced. And we'll look at the next slide here. So as you can see, we talked earlier, arachidonic acid will be produced here, freed from the phospholipid bilayer. Then it will be modified by COX-1 or COX-2 to eventually become PGH2, prostaglandin 2. And from here, you can see the variability of how many different derivatives of prostaglandins can be made using PGH2 as that precursor. So that is a huge step. These COX enzymes are going to produce PGH2 or convert arachidonic acid to PGH2, and from there, there's a variety of different courses that PGH2 can take to be different prostaglandins. So notable prostaglandin we'll talk about. We'll only hit on a couple because there's so much that goes with prostaglandins. But prostaglandin PGE2, its main effects, it's going to increase cell permeability, increases cell proliferation, increases cell migration, and essentially all these are going to promote inflammatory processes. And we talked about in class a while ago, aspirin can actually inhibit COX to prevent this prostaglandin from being formed. So aspirin, that's why it has anti-inflammatory effects, is because it's going to shut down the COX enzymes or inhibit them at least. So these prostaglandins can't be formed that are going to have pro-inflammatory effects. So PGE2, a very notable prostaglandin. And the next one we'll talk about is prostacyclin PGI2. So what PGI2 essentially does, it can inhibit platelet aggregation. So essentially, it can mess with blood clotting. So if these are at very high levels, you're going to have a hard time, if you have a cut, to get the blood clotting you need to essentially get a scab and have that heal over. So it can be kind of dangerous if this is if found in high amounts. PGI2 can also promote vasodilation, the relaxing and widening of blood vessels. And also, has been observed. This is a little bit of a newer function that they have studied, but prostaglandin PGI2 has been observed to inhibit intestinal epithelial permeability and apoptosis. And if this is able to inhibit this, this can actually help treat colitis in those patients that have such a condition. So again, we're only really scratching the surface here for sake of time, but prostaglandins, they have tons of different effects, and a lot of times they can be really good targets for drugs because they have effects in the body that can have a huge impact, such as platelet aggregation or inhibiting platelet aggregation, or as we see here, vasodilation. And I'm sure there's so much more that we're going to find out about prostaglandins and their variable functions. But here's my works cited. Thanks so much for watching, and I look forward to watching the rest of your guys' videos. Thank you.